Hey everybody, this is still 9.5. We're still finding the derivative using that thing called the power rule where you bring the exponent down in front. The only thing extra is we're going to do that whole tangent line thing, but don't panic. And then we're going to do a word problem with velocity, but don't panic. And then we're going to do some funky problems at the end that seem like you can't use that power rule. Okay, so let's look at this example R. Okay, it says h parentheses t 3 over t to the 1/2 minus 8 over t to the 2 over 3. Okay, so our final answer, since we started out with letters in the bottom of our problem, our final answer is going to have letters in the bottom of our final answer. Since we started out with fraction exponents, our answer is probably going to have fraction exponents. Whereas if you look at this example with the x in the house, since we start with an x in the house, our answer will probably need an x in the house. I'm not sure exactly what all your homework takes. Okay, so first, I see my exponents, but they're in the bottom of the denominator, so I need to pull these babies up. So we're not taking the derivative yet. We're just cleaning ourselves up. Okay, so this is going to be 3 t to the, when I pull it up, it becomes negative. And then minus 8, because there's an 8. And then I'm pulling up that t to the 2 over 3, but it's going to be negative. Okay, now we can finally use our derivative. So I have not taken the derivative yet. All I did was rewrite it to something without a letter in the bottom, because that's scary. Okay, so now we're going to take our exponent, negative 1/2, bring it down in front, and we're going to have negative 1/2 and then a 3. But that looks weird. So maybe I should put like multiply, or maybe even a parentheses. It doesn't matter. Either one. And then t to the, I need to subtract 1 from this exponent. So if you're going to put it in the calculator, you have to use parentheses. So parentheses, negative 1 divided by 2 minus 1. And I get a decimal back, so press math, enter, enter. And that becomes negative 3 over 2. Or, if you want to know the mathy way, we take this negative 1/2 that's in the air already, and if I want to subtract 1, that means I need a common denominator. So I need this sucker to change to a 2 on the bottom. So I'm going to multiply by 2 over 2. And you get negative 1 over 2 minus 2 over 2. And heck fire yes, that's where I got that negative 3 over 2. Sweet. Okay, now let's do this next piece. I'm going to take this negative 2 over 3 and bring it down in front. So I'm going to have minus, there's an 8, and then negative 2 over 3, I'll put in parentheses, and then t to the whatever negative 2 over 3 minus 1 is. And you can use a common denominator, or you can just put it in your calculator. You guys have so much stuff to remember, I'm desperate. So I get negative 5 over 3. Okay, the last thing is we're going to clean up this parentheses multiply, and then we're going to put our letters back in the bottom since we started with letters in the bottom. Okay, so let's multiply this. Negative 1/2 times 3. You can put it in your calculator. And I got a decimal, but then you have to press math, enter, enter. So if I would have started with decimal exponents, I could end with decimal exponents. But I started with fraction exponents, so I have to end with fraction exponents. Okay, anyway, so this negative 1/2 times 3 is a big fat negative 3 over 2. Then we have a t to the negative 3 over 2. Then let's do this negative 8 times negative 3. Woo, negative 8 times negative 2 over 3. Whew, math, enter, enter, and I got a 16 over 3, and it's a plusative. And another reason it's a plusative, besides that the calculator told me, is this double negative multiplying together makes a plusative. Okay, and then we have t to the negative 5 over 3. Okay, the last thing that we're gonna do is we're gonna take the t's with the negative exponents and we're gonna go backwards. We're gonna put them back underneath. So at the very beginning, we had t's in the bottom with positive exponents and we had to bring them up and they became negative. Now, we're just gonna go backwards. We have negative exponents. So I'm gonna take that t to the negative 3/2 and it's gonna go on the bottom of this fraction that's beside it. Then I'm gonna take this t to the negative 5/3 and it's gonna get stuffed in the bottom near this 3 in the fraction beside it. Okay, so let's go. We're gonna have a big old fraction, plus sign, because there's a plus sign, big old fraction. And over here on the left, we still have negative 3/2 from just these naked numbers. But then this t to the negative 3/2 goes back underneath and he becomes positive exponent. So that 3/2 is in the air, it's a positive exponent. Then for this sucker, it looks like we got a naked 16 and a 3. But then that t sucker is going back underneath and now his exponent is positive. Hey, that looks horrible, but it's the answer. It's scary. Okay, let's look at S. It looks like we have a letter in the denominator, so we're gonna have to pull it up top like we did on part R, and that will involve a negative exponent. And then we have a house. So let's try and remember what this house means. If we look back at our 9.5 tricks, old math to remember. If there's a house with a 4 in the crook, it becomes x to the 1/4. Okay, so this problem is the same as negative 8 over x to the 1/4. Because remember that old math that we just talked about said if you have a 4 in the crook of the house, it becomes a 1/4 in the air. So I have a 4 in the crook of the house, so it becomes a 1/4 in the air. Okay, but then I can't have that letter in the bottom yet. We don't know a rule for that. So I'm gonna take this x to the 1/4 and I'm gonna bring it up next to that negative 8. And when it brings up, that exponent becomes negative. Okay, now we're finally gonna take the derivative. Remember, to take the derivative, you take this exponent, bring it down in front. So I have a negative 8, then there's a negative 1/4, but that looks like they're subtracting. So I'm gonna use parentheses or a multiply dot. And then x to the whatever negative 1/4 minus 1 is. And you can use a calculator or a common denominator. If you use a calculator, make sure you press math, enter, enter. And I got negative 5/4. Okay, the very last thing we're gonna do is we're gonna multiply these parentheses. We're gonna take this x to the negative and we're gonna throw it back underneath. And then we're gonna take these fraction exponents and throw it back into a house. Yeah, okay, so the first two things that I did was not find the derivative. It was just clean it up. Then I took the derivative and now I'm gonna clean it up again. So I'm gonna take negative 8 and multiply by negative 1/4. And that becomes just a big fat 2. Woohoo! X to the negative 5/4. Okay. But then because of this negative exponent, I'm gonna throw it underneath. Throw it underneath what? The 2. So I get 2 over x to the 5/4. So the step I just did is not the derivative. I'm just rewriting it. The same as something else. I'm just rewriting it. It still means the same thing. It just looks a little different. Okay, then I need to remember my old math for how to turn this fraction exponent into a house. Well, let's look. It's right here. 64 to the 2/3 means the 64 and the tiny 2 stay together inside, but then the denominator goes in the little crook. Okay, so the big fat 2 on top stays the same, but the But then the x and the 5 in the air, it's going to stay together. But then that 4 becomes the crook of the house. So we'll put a house on top of that x to the 5. And then the 4 becomes the crook of the house. Okay, so the only reason the x is inside a house is because that x was attached to a fraction exponent. And since we started with a house, we have to end with a house. Yay, done with that problem. Okay, let's look at this sucker. It's a word problem. I tried to only write the important words, so don't freak out when you get to it. Okay, it gives us f of x, and it says f prime of x. Well, that's just the derivative. Okay. Then part B says x equals -3. What's the slope? Well, you just plug in -3 into what we got for part A, the derivative. Then for part C, it says, what's the equation of the tangent line? That's that y equals mx plus b business. And then part D is kind of new. It says x equals what when the tangent is horizontal? Well, in our tricks, it says, oh, here it is. How to find where the tangent line is horizontal? Use one of the shortcuts above to find the derivative, which is what we do in part A. And then it says equal it to 0, factor and solve for x, or plug the derivative into y equals and look for some x intercepts. So either way, we either factor or use our calculator to find some x intercepts for this last part. But the key is that equal to 0. And that's because on a graph, lines that go side to side have a slope of 0. And if the derivative is the slope, then that's why we take the derivative and equal it to 0. Because horizontal lines have a slope of 0, and the derivative means the slope. So we just equal it to 0. Okay, so let's go back. First, part A, we got to find the derivative. Okay, that's where you bring down the exponent in front and multiply. 2 times 4 is 8. Then x, and you subtract 1 from the exponent. So 4 minus 1 is a tiny 3 in the air. Yes. Let's look at this middle term. You take this 2 and you bring it down in front and multiply it with that -4. That 2 exponent with that -4, when you multiply those, it makes -8. X to the subtract 1 from the exponent. 1. Then the derivative of just a number, if we look back to the very first thing on our 9.5 tricks on the right, the derivative of a number is just 0. So this 1 just goes away to a 0, and I don't even have to write it. So part A said, what was the derivative? Hey baby, here it is. Yes. Part B says, hey, what's the slope when x is -3? Well, the derivative is equal to the slope. And what is our derivative? 8x to the 3 minus 8x to the, I'm not going to put that 1. Okay? Okay. So now we're going to plug in -3 into these letter x's. So 8 parentheses -3 close parentheses cubed minus 8 parentheses -3. Oh gosh, how is this going to turn out? Okay, so when I type this in my calculator, these dashes on these 3's, that's the negative button. But then this dash on the 8, it's the minus. Careful, careful. Okay, so let's see. We're going to have 8 parentheses -3, and I press that negative button in the bottom right. And then to get that 3 in the air, you're going to raise it to the roof, as in press this little arrow button above the divide. type a 3. And then I'm going to have to bring myself back down because I'm in the air right now. So I'm going to press a right arrow button and it brings me back down. I'll show you in a minute how your calculator will look if you don't have that 3 in the air. You can fast forward. Okay, so -8 parentheses -3. And holy poop, I got -192. And that is my slope. It's awkward, but it's okay. Okay, let me show you what your calculator will look like if you have one of those old calculators, if your screen isn't backlit. I just figured this out. Okay, for you guys, you'll have 8 parentheses -3, close parentheses, but then when you press the caret, it doesn't take you to the air. Your exponent just sits there. Yeah, darn. So when this happens, let me see if I can type it in all at once. Oh, I can. Nice. Okay, so if your caret does not take your 3 to the air, it's okay. Just still type. Keep typing. You still get -192. Okay, so let's look at part C. Part C says, what's the equation of the tangent line? Well, that's y equals mx plus b. And that slope from part B, that's the letter m. Okay, the x value that they gave you, -3, -3, that's the x value. The only thing is we don't know the y value. So I know this m is -192. I know my x is -3 from the word problem. We don't know what our b is, so let me write plus b. But then I have to figure out what my y value is. Darn. Okay. So to figure out my y value, I'm going to take the -3 that was in the word problem, -3, and I'm going to plug it into all these x's right here. So 2 parentheses -3 to the 4th minus, yeah, I'm running out of room. Ugh. Okay, so to find the y value, you take this -3 that they gave you and you plug it into the original in the blank screen. Ugh. Don't forget to drop yourself down to the line when you're finished with the exponent. Okay, and I got 127. Okay. So that's what I'm going to put in for the letter y of y equals mx plus b. So I got 127. Woohoo! Okay, we're just going to do the math and clean it up. This makes 127 equals 576 plus b. Then we're going to get b by itself. So let's subtract 576. And I got -449. Okay. Let me just come up here. So I got -449 equals b. But then, if we look back to these steps, I think these are the same steps from the previous sections. We are finishing it by plugging in the numbers to make y equals mx plus b look like y equals a number x plus a number. So y equals a number x. What number did we put in for this m? -192. X. And then what did I get for my b? For y equals mx plus b? My b was -449. Hey, okay, that's the equation of the tangent line. Hallelujah. Okay, part D says x equals what? When the tangent is horizontal. Okay, so it's not saying make this equation equal to 0. It's asking for the tangent line to be horizontal. And if a tangent line is horizontal, if any line is horizontal, the slope is 0. Well, for us, the derivative equals the slope. So whatever our derivative is, we're going to equal it to 0. So let's see, our derivative is this 8x to the 3 minus 8x, and it's equal to 0. And then there's two ways we can find what x is going to be equal to. We can solve by hand by factoring, or we can plug this bad boy into y equals, look at the graph, or press the second graph, and look for our x-intercepts. I think I'm going to do that one. It'll save us time. So I'm going to plug this bad boy into y equals the derivative, 8x cubed minus 8x. Don't forget to bring yourself down from the air. Okay, let's go to my graph, and I'm looking for where across the x-axis. Well, I see maybe -1, 0, and 1. Let's go to our t-chart. Where I cross the x-axis will have a 0 across from it. So I thought it was -1, 0, and 1. So I'm going to press second graph. And I thought at -1, 0, and 1 there were x-intercepts, and there are because there's zeros across from them. Woohoo! So this is x equals -1, 0, and 1. Woohoo! Hola.